Thank you. You got your hand up.
Yeah, I was trying to order those, and I went through 3 different people, and they kept canceling my order. And one guy said, "Well, here's the 300, which is the according to the specs, they say it's the same speed and all the same specs, but so I don't know why there's a 300 instead of a 200. Well, actually, the 300 is supposed to have 300 kilograms of force as opposed to 200 kilograms of force. But it seems to me you can't do that unless you change the gearing, which is going to change the speed of it. But the third guy said, "Well, here, would you take this one instead?" And I said, "Yeah, I would if it's the same price." And then he canceled my order, so apparently he wasn't going to give it to me for the same price. So I'm going to wait a while and see if that all settles down, and maybe they'll start selling them again. I don't know if they just decided to cancel that one because the bigger ones are selling better, or they just had a production problem where they weren't making them or whatever. So we'll have to wait and see what happens on that.
Well, I did have the opportunity while I was back in Iowa to jump in my brother-in-law's big four-wheel drive John Deere tractor with a 60-foot, 30-some row planter on back that's all GPS controlled. So that was fun to see state of the art on how a lot of this is being utilized currently. And the nameplate on his control system is all John Deere. I didn't even see any aftermarket names on it. But it was interesting. The GPS controls every single row on the planter. It won't let you overseed. If your row overlaps a little bit, it shuts those off. If you're doing a little half moon shaped, it knows it, and it'll only plant where the seeds need to go, even though you're overlapping on both sides of it. I was surprised they've got it that refined.
Wow.
And that was without any RTK on his system.
Well, can I break in here?
You bet.
I just went to a economics meeting at Kansas State, and the head of one of the big stock companies that looks at farm machinery says that John Deere's doing everything they can to make sure that nobody has access to their CAN bus. There've been a lot of federal suits about it, and they're losing, but they absolutely do not want aftermarket stuff hooked to their equipment, and they're getting really nasty about it. And I can see why, because somebody gets in and messes it up and then hurts somebody. It's their liability, but also they're trying to build market share or maintain it. But what they do is really incredible. Like you say, the row shut off and all of that. They're doing it right.
That right to repair your own equipment, that's been going around back and forth for the last few years.
Yeah, that was a big part of her discussion. Was it went clear back when Henry Ford built the first cars, his first cars. He put bolt heads on and inserts that nobody else had tools for, just so it could only be worked on in a Ford garage. And of course, somebody came along and made pirated versions of it, but it's not something new to try to maintain.
Well, one of the fun parts with open source is being able to share and then bolt on technology. So we get tractors out moving around, we can bolt on the ag GPS, or we can use different aspects. So
there was a funny article I read today online. I can't give you a reference, but hackers who are diabetic are searching out old Medtronic insulin injector pumps because the first one weren't hacker proof, and they've been able to hook up their sugar measuring monitors to the insulin pumps, and instead of spending 14,000 for a pump, they're able to do it for 400 or 500 for a used Medtronic's pump with an Arduino. Now, being a retired doctor, my idea of fun is not having something I built control my sugar level, but apparently it's a really big deal. And every time one of those comes up on eBay or someplace, it's snatched for between $500 and $1,000 for an old piece of medical equipment, strictly because it's not right protected.
Wow, big demand. I think open technology is important, and food matters, and open technology in food is important. That'll be important for our future.
So this is one of my major accomplishments for the day. I started my logo sheet of logos to put on my new vehicle. So I got those printed out, and I guess I have to put a Raspberry Pi on now if I put a Raspberry Pi logo on it. So
Nice. Those big sticker paper, so you can peel those off like decals.
no, I just plan on regular paper right now. So I'll just use some Scotch tape right at the moment to put them on. Makes it easier to replace them that way, so I move them around.
It's awesome. Sam, how's your week been?
It was busy, mostly work. I had a little chance spending time on, the project that I'm working on. But I did actually look into some of the Python libraries, which are really useful. So there are a couple that I really wanted to learn. So I think spend some time around those things.
Awesome. Alan, did you make any progress learning ROS this week?
No, sadly, I haven't spent any time on ROS yet, so I'm still convinced I need to go there, but I haven't tried to install it yet. So here's a question. Is it easier on Ubuntu or on Windows?
I've only ran it on Ubuntu.
It's the same if you're, this is Sohin. It's the same if you're using Windows 10. You have to go into settings, and it's called Windows Subsystem for Linux. And you basically install a Linux machine on your Windows, and you can access it through an app or a PowerShell or a CMD prompt. So after that, that extra part, it's basically the same. But I would recommend you just go use it on a Linux machine, because later on it might be easier to just mess with a Linux terminal. And that's a personal preference though.
Yeah, got it. Okay. Yeah, I think sometime, I don't know if I'm ready to do it tonight, but sometime I'll kind of show you guys some of the things I've worked on over the past couple of years. And I definitely think that I need to shift over to ROS. ROS is 10 or 100 times better than what I've got. So it's just a matter of getting over the leap, making the leap and getting there. So.
I just set up a new machine this weekend, and I installed Linux or Ubuntu, and then used that ROS.me script from Lino Robot, and that was smooth. It was just one bash script, and everything was installed.
Do you have a link to that, or is that a website you can point us to?
Yep.
Yeah, I think it's on rosbag. Yeah, I remember. I just had a Ubuntu VM on my Windows, and then ran the script Matt pointed out. I was done within 5 minutes. I know I tried installing that without the script, it was painful 2 or 3 days. So definitely recommend that script.
Okay. Well, that's good to hear. I've tried a couple times and ended up stopping. And so if there's an easy way to get up and running, that's awesome. And I mean, I think even something like Docker or something like EC2 instance on Amazon, on AWS would be a good way to go too. If we can get something like that out there that people can just grab and use, would be another good way to do it.
I forgot to mention with Windows, you're stuck with melodic because Windows doesn't have a trusty, I think, version that you can use with WSL. Maybe there is. I'm not so sure, but I was under the impression that you're stuck with melodic. So I'm gonna find out a bit more about it.
If you want to run a virtual machine, Ubiquity Robotics has a virtual machine already set up with ROS. But
That sounds great too. That's really good.
On this Windows 8 laptop that I recently acquired, that was the download I did, and it all installed pretty seamlessly, just like it said it would. I didn't have any issues with that download.
that's a big step forward over a year ago when we were installing it by hand. I think one of the value of ROS agriculture has been just the input from all the people finding different solutions and sharing those. So it makes it easier as we move forward.
If you're using the Conda distribution on your laptop,
Right.
you might have to actually change the path, the Python path. But if you're not, then I think you're okay.
And that's with the Ubiquity?
No, with the regular.
Just regular install. Okay, gotcha.
Yeah. So if you have the Conda, you just might want to watch out for the Python path. Otherwise, you're okay. If you don't have the Conda, or you just need probably 2.7.
Okay. Yeah, I've got, I've switched over to, I'm dual booting with, it's Ubuntu, but it's Ubuntu, however you say that, and Windows 10. So I can go either one that way, and that works really nice. And then I do have Anaconda installed, so you're right, I'd have to work on getting around that. But that's not too hard to change the path.
No, it's just as long as it's in the path, I think you're okay.
Okay.
Good evening, Al. How's your week been?
Well, as typical, you make a little progress and you hit a little block and you work through the blocking issue, and it's been no different. So really happy to get my motor mounted, to get the steering shaft physically connected to the motor mount, being able to turn it by hand without any binding. Got a magnetic sensor to detect rotation installed. Desk check running on an Arduino worked fine. Struggling to get the I2C communications working on the Teensy. So now I'm back doing it on the desk, and so I've that's my Teensy with pull-up resistor installed, trying to get the wire library working, not having much luck. So at the moment I'm stuck trying to get the Teensy to talk I2C so that I can read my magnetic rotation sensor. And again, works on the Arduino, just doesn't work on the Teensy. So I've got to figure out what the difference is there. And this is where somebody jumps in and says, "Oh yeah, I had that problem. Here's the answer to that." Maybe I was on mute or something.
I don't
No?
know.
Anyone?
I haven't
Anyone?
tried it. I ran into some 3.3 volts versus 5 volt difference. If I test it out on the Arduino and it's 5 volts and then move to the Teensy and it's 3.3 volts, but I haven't tried the I2C.
Yeah, the magnetic rotation sensor is, they have an SPI version and they have an I2C version, and I've been trying to make the I2C version work. And again, there's some peculiarity between a plain Jane Arduino Uno and the Teensy 3.5, and the answer is out there. I just I haven't stumbled across it yet.
The forums on the Teensy site have been helpful. I've posted up there a couple times.
Yeah, thanks for that. I did find those. I haven't posted there yet. I was trying to do my trying to be a good forum poster and do some research myself before turning to that. So I suspect that will be in my future, though. So it's all good.
Baby steps.
That's right. I mean, because for me, it was to get even a hello world character message published from the Teensy through ROS into the RPi using ROS serial, being able to echo that topic on my laptop. For me, that was, woohoo.
That's a lot. That's a big step.
So, anyway, we'll get there.
Good
How many
progress.
evenings did it take to get the message to flow through Ross?
I said again, I missed the first part of that.
How many evenings did it take to accomplish that task?
Yeah, I go to work and I work on this. That's all I do. So it took a week, I would say.
This refreshes your mind, right, Al?
Exactly. It's my relaxation.
It's relax. The messages from the sensor makes you relax.
That's all I have, Matt.
Thanks, Al. I was wondering if it's time for Jim to hook up an Arduino to his ROS install and see if he can get messages back and forth. Or is that too soon?
That will be a goal here probably in the next 30 days anyway.
All right. It's interesting like onboarding. One of the goals is to try to make it easier for people to take the pieces of the technology and put them together. So Al's done a really great job at documenting. He can go through and write that out. And so then the other thing is to try to write scripts or try to package the software in ways that make it easier. So Jim, if you feel like you're a guinea pig, you kind of are, but we appreciate your feedback and trying some of these steps. And if they don't work, then we'll try to go through and fix them.
Yeah, I've seen Al with a lot of posts as I look through the trail that I'm trying to find. I see Al has left a lot of tracks.
Yeah.
I mean, just to reiterate, the posts might be helpful and interesting. In the G drive, that's where the milestones and the sort of the breadcrumbs of documents are posted. Again, don't be gentle. They're not production quality, but they probably will help you. And I'm happy to talk to anybody through them if you get to that point.
Good
I
evening.
haven't even got this machine set up to talk to an Arduino yet. My skill level with the Arduino was I could change the little blinky light on the previous machine.
That's a big step. That's
Yeah,
uploading.
that was huge.
Yeah.
I can relate to Al's euphoria for accomplishing his task.
Sometimes when I find a piece of software that I can download onto the Arduino and then have a little wiring schematic, and then I get it all working, and download the software and then fire it up, and it works, I just feel like a genius. I was like, that is amazing. Probably like the simplest task for like an electrical engineer or somebody, but it feels great.
It's just not downloading the software, right? Getting that work and all those, getting the interfaces work and debugging those to make sure that everything is working. That's the hard part. And once you have the mental workflow of how to backtrace and debug that, then you'll start replicating those interfaces and really get good at that, right? So
Yeah, it takes a few times to work out the bugs and figure out what's going on. But that's
Yep. Sounds familiar.
it's really powerful.
after doing that for 14 years,
For 14 years.
14 years, I don't want to do that anymore. But it all sounds fantastic.
Kalyan, how's the perception team? Any updates?
It's going good. Was able to finally get. I was able to get finally my web app up and running. The only challenge I have now is displaying the image on the web page, so I can share real quick. So now we have a Flask app, and I haven't done some of this web stuff, so I'm very similar to how we were talking about the W stuff. These are like the baby steps for me. So we can come here and let's say I pick the weed here and I say upload. So right now it goes and it invokes the TensorFlow library, and then in a couple of seconds it will start crunching the numbers on it, and then it will do a prediction on that. So it just did it and it finished the prediction. So now I can go and see that I have my image here with all the weeds. The challenge has been like now with all the web interfaces, I'm not able to display the image properly. So I need to get this one working. I think after that, we should be in a good shape for actually start training models from web interface. We'll start picking that up.
That was really good. You were doing more. You were doing each sub image.
What was that?
You did object detection, and you had the percentages for every single object in that image. So that was really good.
Yep. Yeah.
Kalyan, it cut out.
Sorry. Yeah. Sorry. Sorry about that. Yeah. So we got this working on a Python script. Now it's more doing that engineering work to make it web interface here.
Leon, is that
You have your labeled data. Was your labeled data? How did you do that?
How did we do the label data? Let me make sure I understand it. The annotations on it?
Yeah, did you go through and annotate images that had multiple plants in each image, or did you have images with only one plant per image and then trained on that individual image that way?
Right. Yeah. So It works either way, even if you have multiple pictures, or single picture on it. The YOLO algorithm works in terms of training that. But once it detects it, then yeah, it will. It can, once the image is trained, the image set is trained, then yeah, it can go and predict these, even if it has multiple objects on it.
Yeah, that's very good.
Kalyan, is it possible for you to share it on the Git?
Yeah. So once I can display these images, I'll probably put that. I'll definitely start sharing that on the web.
Okay.
The only I think possibly we're very close. Yeah, we can definitely share that. The only other one, I don't know if you guys noticed, but whenever we were loading this, it was taking a couple of seconds to load the TensorFlow backend and process that. So we might do some more optimizations on loading the engine and the TensorFlow engine, and then not stopping it. So right now, every time we upload the image, we are starting the engine, processing it, and stopping it. So once I get to a point where I can get the image displayed on the web page, and then optimize it so that it does not restart the engine for every file upload, I plan to definitely share that with everybody on the GitHub.
Got it. Yeah. No rush. I mean, it's just the Flask is also the interesting part. I know a little bit about it, but not much.
I'll be happy if somebody can take that and make it much more flashier and enhancing than my boring web page there. So
Well, yeah, we need someone with the React or JS, right?
yeah.
Yeah, for a fee, we can get it done before next meeting.
Well, what would that fee be, Alan?
I don't know. Isn't that the way with everything, though, right?
Yeah, I got some basics for HTML, CSS. I really suck at the JavaScript, so sorry, I can't really help.
Okay.
Yes, maybe that's the opposite of open source too. If we hire somebody to do it, huh?
So, but we have the software, so we can edit it. It'd be nice the UI piece is a very big part of all the robotic software. So we have this underlying code. Kalyan's a systems engineer, so he has a very good understanding of how to put all the pieces together in a working system. But that other UI piece, we'll definitely need some help to build that out.
Yeah, very interesting.
So if you have any UI or front-end developer, web developer friends, invite them in.
Yeah, definitely. Also on the database side, Kalyan, are you planning to store those images, use like basically some kind of a SQL alchemy or something?
So it's a good question. So for prediction, I don't plan to store the images. So every time I have a new image uploaded, I might delete the old images. But when we are training the data set, that's when I probably plan to use a database. The idea would be that, like I think I mentioned last time, the database would have links to the files which are there on somewhere else on the web, and then using the links we would download all the data, and then once the training is done, we want to delete all those images back again, unless we feel that okay, we don't want to re-download all the images again and again.
Got it. I was actually looking at one other project where we're somehow optimizing it through Number, and they're also using the Dask structures. they're super fast, super cool. So I'm not sure if that's something your engine probably would use on the TensorFlow side or your YOLO, whatever it is. I mean,
Yeah,
just
right now, yeah, right now I'm not using any of that stuff. The TensorFlow stuff, ideally, if we have GPU, it would run on it, or if you have CPU, it just runs on it seamlessly. If we if we don't use TensorFlow API, I could see a use case for Numba and other packages. But right now, the TensorFlow takes care of the image transformations and also the image detection algorithm.
got it. Cool. I didn't know, so I was looking at it and I thought that might be useful input maybe.
Yeah, it's definitely good to know. I've heard about it, but I haven't used much of that.
I heard really nice things about those things. If they're like 100, sometimes degree of order of 2 or 3 times faster. Actually, it's just amazing how to do it. I mean, they're at a point where they're saying that the speed is as good as if you're writing it in a C++. You know. Somehow they're making it work, they're making it fast, and it's very much optimized. The only thing that you should have is, I guess, the NVIDIA, because they're like all need a CUDA and then your MKL on top of that, so it just makes things faster. But if you,
Yep.
yeah, if you and Intel, obviously.
I could see the use case for that. I could see the use case for that. I don't know much for perception, but I could see it for like the sensor fusion algorithms and all. If somebody wants to write in Python from scratch, I think the Numba library would be probably a very good library to use.
Yeah, I agree. I think so too. I mean, I haven't tried and leverage anywhere yet, and then the driver level of the writing for the sensor fusion is like probably beyond my current skill sets, probably. But I think I do see that could be potentially be exploited, and I think it would be a very good idea because it's just super fast.
Yeah, it looks super cool. Like the API is also professionally packaged, so
Yep,
I would
I
love
agree.
to see something to explore. This might go into our long list of things we want to explore.
I know it's never ending. No matter how much you get into and you learn, just something out there tomorrow.
Yeah, but we always have people in the group always looking for things to try out. So this could go into that list. Things to
Yeah, I
try
mean,
out.
yeah, the perfect place for the knowledge and information share. At least if
Yep.
that would help, because I was looking at it last time and I came across the X-array, and I was looking at the use cases too. Just awesome. I didn't know that these things exist.
Yep.
And I think the NumPy in ROS has lots and lots of use cases. And when you use NumPy, obviously, on the Python side, you might be able to also, I'm not sure people have done it. I think one of the limitations, I'm not sure if that is so much true, but I think ROS is natively supports 2.7. I'm not sure. I think go up to 3.4 or 5 or something. And I'm really not 100% sure that, if the Python 3.6 or 3.8 is just like seamlessly supported without any issues with the ROS. I still use 2.7, but I think it's just getting retired, right? There will be no bug fixing going forward from 2020. So I'm not sure what's the ROS side of things would be. I'm not sure if that would have some updates that would get us migrated to 3.7 because 3.8 is at the horizon, right? So there 3.8 early betas is already out probably. So yeah, I'm not 100% sure that how the support would be with 2.7. I mean,
Are
sorry,
you all
7.
are you using Python 2.7? Are you all
Yeah,
using Python 2.7?
I do.
Oh,
I'm
okay.
in 2.7.
Okay.
I mean, I do both.
Okay.
I mean, I do 3.7, I do also 3.6 and 3.7, but that's for the different projects. But for the ROS, I got this 2.7.
I see. For the raw stuff, you're using Python. Okay.
Yep.
The other perception project is the row following, following the plants and using that as localization. And Mama posted a link, but I think he's around maybe 60, 70% accurate now with that machine learning
That's
script.
cool.
So
That
still
is
some
very
more work to do there, but that you could use a low-cost GPS, just get you near the row, and then you'll use your camera to steer down the row, guided by the plants.
Yeah, I saw the progress they're making. They're running at a very fast pace too, which is amazing.
Yeah, he wants to get in the field this month, May. He wants to go do testing, so they're kind of pushing to move forward.
That's cool. That's inspirational. He's definitely pushing us to be up on our toes, right? So
Yeah, it's good. Thanks, Kalyan. It's cool. Sohin, did you get a chance to work on the obstacle detection?
No, but so I've been thinking about making the topic that you subscribe to as a parameter itself. That's what I'm working on right now while we're meeting. So trying to squeeze some work in while we do that. No, I haven't had a chance to work on anything over the week, but yeah, this is what I'm planning to do. Well, I'm trying to do right now.
So it would be like a safety topic that we could subscribe to?
Um, no, so the safety topic would be the safety topic, but this is a topic that the safety node should subscribe to get data from the sensors. So I'm trying to make it dynamic in terms of being able to subscribe to /scan basically for laser, or if you want to just use our regular HCSR 04s, then maybe if you want to publish on a different topic than /scan. So making that topic that your safety node subscribes to as a dynamic topic, so you can subscribe to multiple ones. It might be a better idea to have multiple topics or to be able to subscribe to multiple sources for the safety node itself, but I don't know. I'm not so sure about that yet. So I have lots of ideas. I'm just trying to implement it and see what works out and what doesn't. So yeah.
so are you using ultrasound sensor?
Yes, for now I'm considering to use ultrasound sensors, but with the simulation that Matt has up running, it's using, I think it is what it seems to be is laser sensor, and then we're receiving or receiving a scan message that has it's basically a point cloud, or no, it's not a point cloud. It's whoops. My Siri started working. Sorry. So yeah, it's publishing or it's listening to a laser topic right now, but I want to use it for the ultrasonic sounds, ultrasonic sensors.
The one you got working, Matt, the laser is spinning, or is it just static, but it looks at multiple angles?
Someone brings up a really good point, and he's talking about the message types. So the message type that's currently in the simulator is a laser scan. So there's only 4 returns, and it's simulating basically a sonar. But the data is packaged into the message type laser scan. And he brings up a good point that we really need to have one just for like an ultrasonic sensor, and maybe that message type is maybe like a float 64 or something, and we return that data. So on that sensor node, how do we make it flexible to be able to maybe read in a laser scan if we happen to have one, but then also be flexible enough to add just the sonar itself, and maybe we could listen to 4 or 8 of those topics. Anybody have any thoughts about individual sensors versus packaging the so the laser scan packages all of the sonar messages and returns that in a specific message type instead of each individual sensor being sent out on a topic.
Is that you have to use the laser scan, or there's a range, right? Like, is that can be used or not?
Yeah, that's the sonar or ranger message. I didn't get that working.
Oh, I see.
So I could return as an individual sensor. I don't know if there's a specific message in ROS, like a sensor message for sonar.
Yeah, there's a range, right? There's a range that's for the ultrasonic.
For sonar or ultrasonic, or it may just be like a float.
So there's a range message that's for the
I
ultrasonic.
can't hear you, Sam. I'm not sure what's.
Can you hear me now?
Oh, it's me.
I can hear you.
Right? Maybe it's me.
Okay. Yeah, I thought that something's wrong over here, but I couldn't see anything. So for the ultrasonic messages, I think there is a sensor messages, the range sensor messages. That's standard, and that can be deployed. But I think there's an enumeration for which number that you wanted to use, and let me take a look at it. Yeah, okay. So for the ultrasound, you use 0, and for the infrared, you pass 1. And there is a range, which is the minimum range, is the maximum range. That's float 32, and then there is a float 32 range. So take a look at this message. Actually, I'm not sure if this is what you're looking at, or it might be useful.
Yeah, that someone posted a link there.
Yeah, that's the one. Yeah, the range.
So that's a good idea, I think, to use the standard message type for that sensor. Is that what you were looking at, Sohin?
So I was just looking at the laser scan because I just wanted the simulation to work. But this is a great way to incorporate both of them. Right now we can. So right now how we have it is we're supporting laser scan, but we should be supporting the other messages. But this is also fine. So now we have support for laser scan, and the next stop would be, or the next feature to add would be support for ultrasonic.
Okay. I can work on making those changes to the simulator so it outputs. We can either have it output both, or so we can either listen to the laser scan like it is now, or listen to this message.
Sure. Yeah. I'll see how I can integrate both of those without any lags. I'm starting to think there might be some lags if you're trying to read from both sensor streams. So we'll see.
Okay.
That's all I have.
Good. Thanks, Sohin. It's a good catch. Sometimes it's easy to pack messages into different message types, but that's not necessarily the right way. It causes problems downstream if you want to use other packages. One of the features, if you use the standard message types, then all the other packages that use that message type, you can just download and install them and use them.
Had a quick question. Have you guys done like a record and playback of the sensor data to test some of the sensor fusion controllers? Or like if you have a code run, sensor fusion code running on a controller, how are you all testing that?
Ross has a feature called rosbags, and that records all of the topics. So when you can take the robot out and then you can drive different, what I do is I just drive different patterns. I may just go straight for a long way, do a figure 8 and then do a square. And I record the, it's called rosbag is the command, and it records all of the topic information. And then you can replay that back and then adjust your sensor fusion parameters and test and see how it goes. So you just do one pass, collect the data, and then you can play back that file over and over again.
Okay. And when you do that 8 pattern, what metrics do you guys measure to understand the accuracy of the sensor fusion algorithm?
Magic.
Magic.
So you're wondering what ground truth is, and is the question on how do you tell ground truth?
Yeah, or ground truth, or even like one idea would be how much it deviated from shape 8. I'm just curious, like how do we test these?
That's your systems engineering coming out there. That is a very good question, and it's a difficult question. Quite honestly, the way that I've seen it done is you have some truth sensor that you use to benchmark against. So you can use very expensive lasers, or you can use like a expensive INS system, and then you benchmark that and you say that's ground truth. Without that, what I've been using is the RTK GPS. And as long as I can hold an RTK fix with that, I know from testing that I'm within 2.5 centimeters. And heading has been a little bit tricky to get ground truth on, but
the RTK GPS has 2.5 centimeter accuracy.
Yes.
Okay, so you would use that. So in that case, so you would use that as a ground truth. 2.5 centimeters is perfectly fine with me. And then the other sensors are the IMU and what other sensors we have in our case?
The wheel encoders.
Wheel encoders, IMU sensors, and do we have any other ones?
Well, on my machine, I don't have the vision system for the row following working. So the other sensor would be something like visual odometry or the crop row following for localization.
I see. So using those, we would do that. And what about the initial state for that one, for the sensor fusion, how do we get the initial state for the sensor fusion algorithm? Do we use like a very bad GPS and then take the data from other sensors to fuse it?
That's a good question. I'm not an expert on the sensor fusion, but on robot localization, there's like initial parameters, and they are wider, and then you have your I guess covariance matrix.
Right. I'm still talking about localization only, but I was talking about sensor fusion in this case. More than the environment, I'm very much interested in understanding the position of the robot. Okay.
Yeah, and Matt is right in that way, Kilian. It's the robot localization that actually gets you where you at. Actually, that's what it does. So it actually localizes you either in the GPS frame or like a map frame or into the world frame. And then to answer to your previous question, I've seen that the people have used the controlled environment. It means that, you know, you're not, when you were actually looking for the accuracy, and if you just wanted to see that how much it deviates, you know, you need a controlled environment many times in order to check that. Unfortunately, GPS would not be a great choice when you actually running it with indoors. But I have seen people mounting the cameras and then just try and create the environment where they can check that where they actually are and then where the localization is and then how much they deviate if they're moving from one point to another point.
Right. I mean, I could see, I think the Matt told me once, I think, which I could see that is you could have a factory floor full of markers. And then as you navigate through it, you can, at certain points, you can always look at where the landmark position or fiducial is and get an idea of how much you are deviating and how much error you have in your algorithm.
That's true.
I'm just trying to understand what all methodologies are there and how robust all these are. The other question which came up, we were talking about some of these at work. One of the questions which came up was, does all these sensors need to be synchronized? Like, so how tightly do they need to be synchronized? And there are different problems here. There is localization problem. There is a navigation problem. So we were just trying to understand how much synchronization of these sensors is important for algorithms.
Actually, that's where, you know, the ROS comes into the picture. You know, it takes care of all those complexities, like and takes care of it like behind the scenes. As long as you are using the right package, like for example, in this case, the robot localization. So many calculations behind the scenes. It's got some parameters based on the frequency that how fast you're reading, you know, how many readings does you would need. And there are so many other limiting parameters too that you can specify, but it all helps in the end, you know, in order to get you the right localization. So, and the industry standard, again, you know, I always say that like about 50 hertz. So if you're running, I mean, especially for the agri, I mean, you don't need the 50 hertz, but if you're like able to run it based on the 50 hertz, then you're actually good to go.
50 hertz is the sensor fusion loop rate?
No, well, it could be pretty much higher than that, but I think your end point in terms of localization, that how, you know, how your localization is getting refreshed every few hertz, you know, maybe 10, 20, 30, and if you can go up to 50, that's great.
Okay. And
but
so
you won't get the data really on the high frequency. You know, your sensor data would come in probably on the high frequencies. I think I'm not sure about your GPS, that how much that get that refresh rate from GPS, but all the other sensors probably spit out data really fast.
So I could see, okay, so if we are using a camera, the camera sensor probably spits, let's say 60 frames per second, so 60 hertz. And then if we have a LiDAR sensor, I don't know how often does, Matt, do we have any idea how fast the LiDAR sensor spits out the data, or how fast the IMU sensor spits out the data?
It would depend on the sensor and laser you're using, and then the driver. So there's a lot of variables there. So
yeah. I agree. Probably the spectrum of, depending on whether it's cheaper or better, like they would all throw data at different rates. But but there's a general ballpark, right? Like, you know, cameras, I quoted 60 frames per second, but it could go 30 frames per second to 100 frames per second, really throwing on how much money. So similarly, like IMUs, are they spitting data in kilohertz rate? Or are they spitting data in 100 hertz rate? I'm just trying to get a ballpark of how fast are we getting data from these sensors?
So like there's a price range, you know, variable. So the expensive sensors obviously can send out data faster. at the sensors that I'm using are do simple. I'm doing that at 10 hertz. That's the GPS. And then the IMU is at 50 hertz.
Okay, so IMU in our case is also 50 hertz. I see. Okay.
But the ROS got this concept of buffering too, Kalyan. So it would, if you have more, actually, you were spitting out data at the higher frequency. You have this buffer concept, and then it will actually hold last few recent values for you, and then it will just keep providing you that value.
Mm-hmm.
But it's common for some of the sensors, if not like in kilohertz, like hundreds of hertz, that they run on that. I think it's pretty common.
Okay. Good to know. Thanks for sharing that information.
No problem.
We could have an entire team just focused on localization. It's a big problem. There's a lot of work there. It's fun. It's really interesting, all the different ways to try to piece it together in the sensor fusion. It's fun. There's 500 hertz. Al's got a Tinker Forge. His can output 500 hertz. Then we would have to put a more powerful computer than a Raspberry Pi to start crunching all the data.
Right.
There's other problems.
So you got so much throwaway data then. Or maybe you can do is like real-time analytics through the Dask or NumPy, right? And then use the average.
So at work, we got no problem with the speed of the ECU, right?
Okay.
People are trying to go faster and faster. So that's where now we are. I think at slower rates, it's okay, I guess, as long as the sensors are slower. And also the ag robot might not be going at a faster rate. Maybe I shouldn't say that. If it's a tractor, then it's probably collecting data at much faster rate, right? So it has to, because its position is also updating very fast, so it has to get data from these sensors also a little bit faster. As the speed of the vehicle keeps climbing up, then these sensors have to give an accurate position, in a shorter period of time. And when we are working on autonomous vehicles, like they're going at much faster. The vehicles are going at 100 miles per hour, so the data they want to collect is also faster. And people were talking about this. I was like, I don't know if we really need this level of synchronization. So I was just curious if anybody has run into something similar.
So what you were looking at for the autonomous vehicles, we'll probably be using maybe 1% of that. I mean, we can run easily on 10 hertz without any issues, and that would be really cool too.
Yep.
Are there any other questions or areas people need help?
My PWM board showed up yesterday. I haven't done anything with it yet, but it's supposed to do, I think, 16 channels of 12-bit PWM, I think is what it puts out. And you talk to it with an I2C interface. So that's something to start playing with.
And that will control your LEDs as well as your servo motors?
Yeah, it'll do a 0 to 100% PWM, and to do a servo, you just limit it down to a smaller range to generate those pulses. Actually, I haven't looked at the libraries for it. Adafruit has libraries that'll run it, so I'll have to dig into it and see what I can make it do.
Another toy. Awesome. Well, thanks for being here tonight. Great seeing everybody. Hope you guys have a fun week.
Thanks, Matt. Thanks, everyone.
Great week.
Yeah.
Thanks.